Hello, good day to all of you. India is a growing economy, perhaps one of the largest in the world. The commitment from the government to invest trillions of dollars into the infrastructure pipeline will scale the infrastructure projects multifolds in the coming decade. Do we have enough capacity to meet this demand? Probably not. I think it's our collective responsibility to skill the talent and build the capacity for future. Most of these infrastructure projects adopts drill shafts or bored cast sensitive piles as deep foundation element. I have been interacting with many business unit heads of large corporations and infrastructure companies. All of them are echoing one thing in common. They say that most of their projects have time overrun and cost overrun, mainly attributed to the difficulties and problems they face in the foundation construction. Think about it. How can we mitigate the problems in foundation construction, thus minimize the time overrun and also the cost escalation? Hi, I'm Parthasarathy from Sarathy, Geotech and Engineering Services Private Limited. We are technical partners of Pile Dynamics USA, who have developed cutting-edge technologies for deep foundation testing for the last 50 years. Adopting appropriate quality control tools, of course with care, can to a great extent minimize the uncertainty in deep foundation construction and thus help to minimize the cost and the time for the project. Friends, today we have a gamut of tools and techniques available for the profession to provide complete deep foundation solution. As I already said, that the drill shafts and bored cast sensitive piles are the foundation element for infrastructure. There are going to be many anomalies and uncertainties during the construction. The pile toe could have damage, there could be necking, bleeding of concrete, there could be defect towards the pile top, there could be cracking or breaking of the deep foundation. All of these anomalies has to be evaluated for the foundation performance. How can we do that? So we can adopt certain quality control tools that are available to us. There are two quality control tools that are available prior to pouring the concrete or even casting the deep foundation element. Number one is the shaft area profile evaluator. Shaft area profile evaluator determines the verticality of the deep foundation element, the radii of the pile, and the volume of the pile borehole excavation. We want these elements to be axial or vertical. Any eccentricity induced will have a moment and that will reduce the load bearing capacity of the deep foundation element. The second quality control tool prior to pouring the concrete is SQUID, Shaft Quantitative Inspection Device. The SQUID will evaluate quantitatively the thickness of contamination present at the pile base, and this is very useful for those foundation elements which derives its capacity mostly from the pile base, that is the end bearing piles. We do not want to see the contamination to be present between the pile and the bearing stratum, which if it does, then it will experience large settlements during the static load test. And therefore, if the SQUID can evaluate quantitatively the thickness of contamination, and if you see that the thickness is more than the prescribed limits, there could be some cleaning process prior to pouring the concrete, and thus ensures that our load carrying capacity meets the design requirement. Post concreting, it is also required to evaluate the integrity of the deep foundation elements. There are different methods to evaluate the integrity of deep foundation elements. The first and the very simple test is the low strain pile integrity test. We call it as pit testing. So the pit testing utilizes an axometer mounted on a well prepared flat surface of the pile top, and with a small handed hammer give an impact which induces a compressive stress waves, and the pit testing equipment will record the velocity time history. As long as the geometry is uniform throughout the length of the pile, there will not be any early reflection from this velocity profile, and you will be able to see the response only at the pile bottom or the pile toe. Although the method is rudimentary and very simple, the main objective of this pit testing is to detect major defects. There are several limitations. And a couple of very important limitations are: one, if there is a major defect detected during the pit testing along the shaft, any defect below the first major defect the pit testing cannot identify. Second, there will be an uncertainty in location of the toe because the variation of the wave speed in the concrete between 3300 to 4300 meter per second, about 5 to 10% there will be uncertainty in locating the toe. To overcome these limitations of pit testing, we can perform an advanced integrity test called cross-hole sonic logging test, or CSL. The CSL requires embedding the access tubes along the reinforcement prior to pouring the concrete. Once concreted, the drill shafts could be tested using the CSL using the sonic probes. The sonic probes will be inserted through the access tube. One will be the transmitter, the other one will be the receiver. The sonic waves will be generated, and the time taken for the sonic waves to travel a known distance between the access tubes will be recorded. The distance divided by time is the velocity. The CSL tube will scan 50 millimeters bottom up as we do the testing, and if there is no anomaly, the velocity will be uniform across the drill shaft. If there are serious defects or anomalies in between the drill shaft, there will be a delay in the first arrival time, and thus the velocity will be reduced and the wave speed will be reduced, determining the defects within the drill shafts. So the CSL test can evaluate the quality of concrete only inside the reinforcement. In order to again overcome this limitation, there are newer methods called thermal integrity profile. The thermal integrity profiler or the tip testing will involve embedding the thermal wires with thermal sensors instead of an access tube. As the concrete is curing, the rate of hydration, the temperature is measured with the thermal sensors. Cooler temperature will indicate reduction in the cross section or anomaly. Warmer the temperature indicates there could be some enlarge in the cross sectional area or the bulge. So please remember, none of these integrity methods will give any indication on the bearing capacity of the pile. In order to evaluate the bearing capacity of the pile, one has to perform a load test. The conventional way of doing is a static load test, but static load test putting a cartilage is too time consuming and it may not be practical at many project sites, and therefore we can adopt high strain dynamic test. The high strain dynamic test involves instrumenting the pile top with strain gauge and accelerometer. Pile driving analyzer will capture the force velocity time history. It will also measure the energy transfer to the pile, the stresses to the pile, and the bearing capacity of the pile. As I already said, most of the infrastructure projects adopt drill shafts or bored cast in situ piles. To estimate the bearing capacity of the pile, we use what a sophisticated software called CAPFAP, Case Pile Wave Analysis Program. So this imports the signature from the pile driving analyzer, and then a trial and error analysis is performed to evaluate the pile capacity. CAPFAP is still a gold standard signal matching technique which evaluates the bearing capacity of the pile, not only the total capacity but also the distribution of capacity between the base and the skin. Friends, you have seen so many advanced tools and technologies. For these methods to be put best into use, one requires training and acquire the skill and knowledge through experience. I will break down step-by-step procedures of conducting these tests with clear objectives in my upcoming videos. Stay tuned for more information in my upcoming videos. Until then, happy learning, and I will see you on my next video. Goodbye.